Symmetry is a topic related to routine, and it is mainly concerned with the partition of an object. So when you are doing this topic, you have to remember this is basically a geometrical concept. Let's start this topic. This is the syllabus. This is the syllabus of the topic. This is the syllabus of the topic, and we start with the syllabus line. There are three geometrical symmetries. One is called line symmetry, second is called rotational symmetry, and the third is called planes of symmetry. Now we start with line symmetry. Line of symmetry actually divides a two-dimensional shape into two congruent identical shapes. When you make something from a paper, like a paper square or something like that, you make a line which is exactly going through the center of the figure. For example, this is a triangle. Now, this red line is called the line of symmetry. Similarly, this is a rectangle. Look at these two lines which divide the figure exactly in the mid. Actually, it's a line on which a figure can be folded. This line is called the line of symmetry. Now, this is a square, and you can say there are four lines of symmetry. Line of symmetry divides a figure in between. The figure can be folded on itself. Circle has a very interesting case. A circle has infinite number of lines of symmetry. So you can say you can draw a line of symmetry anywhere passing through the center. So all diameter style lines can become the line of symmetry. Now look at these sum of the letters A, B, C, D. I show you that if I take example of letter A, letter B, letter C, letter D, in this way, every letter can be shown for one or two line of symmetry. It's not necessary that every substance, every figure has a line of symmetry. Some figures do not have a line of symmetry. Now, look at this idea. There are some random shapes. Any shape can come in the exam. These are some random shapes. This is called line of symmetry test. Okay. Now, you can draw line of symmetry from every figure, provided a line of symmetry means that the figure must be divided in two equal halves and figure can be divided on itself. Now, look at this very interesting concept of a butterfly. This butterfly is center part is the line of symmetry. Now we come to the second title of this chapter, which is called rotational symmetry. What is rotational symmetry? This is a concept when you rotate something. After some rotation, the figure achieves the same appearance. I mean, you rotate something, and after rotation, it comes back on its original position, original orientation. Like, for example, these are the letters, and I rotate the letter, for example, H. I rotate it once, 90 degree, once more, another 90 degree, once more, 90 degree, once more, 90 degree. I have rotated four times, each time 90 degree. So I will say one 90. So I've rotated it four times. So the total rotation, if I rotate it, if I rotate it four times, in my one complete cycle, the figure superimposes on itself twice. So the order is two. Let's take one more example. This is letter I. I rotate it once, 90 degree, rotate once more. Now it's back on its original position. Once more, once more. Now, in one complete cycle, it has superimposed on itself twice. This is called the order 2. Now look at this letter N. Letter N is rotated this way. Now you can see again the order is 2. So what is the meaning of the order of rotation symmetry? I rotated this one. Again, you will see that this time the order is 2. Now, what is the concept of order of rotational symmetry? If you rotate something one complete cycle, I mean 360 degree, how many times the figure superimposes on itself? Now look at this figure, equilateral triangle. I mark the point of rotation and I rotate, start rotating, observe it carefully, superimposes once, superimposes twice, and superimposes thrice. In one cycle, it superimposes on itself three times. This is the order is three. Now you have to see this one. If I mark the center of rotation and start rotating it, superimposes once, superimposes twice, superimposes thrice, and now one more 90-degree. Now it is back on its original position. This is called the rotational symmetry of order 4. Actually, order 4 is sometimes called as order 0 also because everything comes back if it is rotated 360-degree. So 360-degree is something which is there for every object. Other angles are important to notice. Now look at this. This figure rotated once, rotated once more. You can see it comes back on itself. And you have to see in one complete 360-degree round how many times the figure is able to superimpose on itself. It's an order of 5. Now you have to see basically if it imposes once complete, if everything has to come back. Sometimes people get a confusion about when we say order 4. Order 4 doesn't mean order 0 actually. It means that I meant to say that if you rotate it and it rotates on itself only one, then it is called order 0. Now look at this. So order is 6. Now, in this way, different objects can be taken. Now, this is a rectangle. You take this one. Now, it rotates once, it comes back, and it comes back again. So, in one complete cycle, the order is 2. When we say order is 0, if it comes back once in one complete cycle. Now, look at this. Now, this is the figure. I start rotating it. It comes back once. And if I rotate it once more, it comes back. So the order is 2. Similarly, different figures. Now look at this one. It rotates once. Now this is order 1. Now this order is sometimes called 0 order. Why? Because everything has to come back on itself after at least once in 360-degree. Now look at this. This is order 1, which is also called 0. Now you have to see this one. So I just go over from here because this concept has been made. Every figure you have to rotate. Rotate every figure and you have how many times it superimposes on itself. Table of the number of lines of symmetry and order of rotational symmetry. I will share the table after the class. And this table can be memorized. I recommend memorizing it. Remember that sometimes we say 2, 2, 4, 1. 1 means that it will come back on its shape again at least once in 360-degree. Now, planes of symmetry. Sorry. What is the concept of planes of symmetry? Now look at the definition. A plane of symmetry divides a three-dimensional shape into two congruent solid shapes. Plane of symmetry has a concept like, for example, you have a piece of cake. You want to divide it into equal half. and you want to share it with another person, then you have to divide the figure right in between and you cut it in between. This is called plane of symmetry. It is actually a 3D concept. Now look at this. This is a cylinder. I have shaded a plane in between and I want to cut it from here. Now you will see I got two equal halves. This is basically called plane of symmetry. Look at this. Right in between the shaded line, the shaded part is showing plane of symmetry. So just consider an apple and you cut the apple right in the middle and make two pieces of apple. When you make two pieces of apple, it is actually two equal halves. Now this is a plane of symmetry. Now we move forward, plane of symmetry, a cuboid. A cuboid has three planes of symmetry. How? Look, this is the first plane of symmetry. This is the second plane of symmetry. And now look at this, the third plane of symmetry. This is for a cuboid, three planes of symmetry. Now we have to explain why that this is not a plane of symmetry. It has to divide it. It has to divide it exactly in the middle. We need to divide it from the center. It's like a wall exactly in the center. Square base prism. So I can make one plane of symmetry. I can make second plane of symmetry. And I can make third plane of symmetry. So this is how we can make planes of symmetry, which should be able to divide the figure exactly into equal halves. Okay, now some objects can have multiple plane of symmetry. Like this one, this is a cube. Look at this. A plane of symmetry divides a figure in 3D into equal halves. Now look at this. This is a plane of symmetry. This is another plane of symmetry. So we can see there are two planes of symmetry. Now look at this, a plane of symmetry in between this prism. And look at another plane of symmetry in between. Look at this, another plane of symmetry. Look at this, another plane of symmetry. So we have, in a triangular base prism, we have four planes of symmetry. Now we have a pyramid. We can draw one plane of symmetry, another plane of symmetry. So a square base pyramid has four planes of symmetry. Look at this. So a regular tetrahedron, this is a regular tetrahedron. Look at this one. So in paper, if you get any figure, you have to see that where the planes of symmetry are there. So in this way, this is a complex example, but you can find multiple planes of symmetry, which you can practice. In a circular shape like a cylinder, there is virtually no limit of planes of symmetry. Okay, so this was the discussion on planes of symmetry. Thank you.